What if the universe's great song of light is not only getting lower in pitch, but also quietly slipping out of tune inside the chords themselves? In the energy filament theory, the redshifts we see and the tiny distortions inside spectral lines are two faces of the same thing. Particles slowly changing their internal rhythms as the underlying energy sea relaxes over cosmic time. Textbooks teach you the simple part first. Distant galaxies look redder because their spectral lines move toward the red side, as if the whole song has been shifted down a half step. That picture is already strange, but recent high-precision astronomy keeps adding a twist. We do not just see whole lines sliding together. We also see the patterns inside those lines deform a little. Lines that should be evenly spaced are no longer quite so even. Some lines are stronger or weaker than expected. Features that should be perfectly symmetric look just a bit skewed. The set of notes is still the same, but the relationships between them have been nudged, as if the band is still playing the same song but some instruments are just slightly offbeat. The usual way out is to blame the environment. Astrophysicists point to messy gas clouds, complicated velocity fields, scattering and absorption along the way, plus calibration and data processing issues in our instruments. All of that is real and it does fix parts of the story. But as the data have improved, some of these out-of-tune features have become more stable rather than less. They start to look less like random noise and more like a cosmic accent that will not go away. And the list of environmental patches needed to stuff everything back into systematics keeps getting longer and more tangled. In this picture, the logic is cleaner. A spectrum is not a barcode stamped once and for all, it is an ensemble performance. Every line is tied to a specific jump between energy levels. And every energy level depends on particle structure, on the electron's internal rhythm, on how tight the proton's filament knot is, on how close a neutron sits to its marginal balance, on how an electron's inner energy flows bends into magnetism. You could say that a spectrum is a group of particles all tapping out related beats. In earlier episodes we already saw that electrons, protons, neutrons and short-lived pairs like positronium each respond to tension in the energy sea in their own way. They do not speed up or slow down together. That is exactly what we meant by the universe and its particles changing out of sync. So when the cosmic tension evolves, two layers of change are happening at once. At the coarse level, all particle rhythms in an earlier epoch were a bit slower than today. That global slowdown shows up as redshift. The whole line pattern sliding towards the red, like playing the same track at a slightly lower playback speed. At the finer level, different structures slow down by slightly different amounts. The electron's contribution changes one way, the proton's bounded structure another, the neutron's near unstable balance another, and their combined energy gaps are no longer in the old perfect ratios. As a result, the relative positions, spacings and strengths of spectral lines get twisted in a small but systematic way. This is the quiet retuning of cosmic spectra. Redshift describes the main melody being slowed. Line-shape distortions describe the harmonies drifting against each other. From this view, they are not two unrelated mysteries. They are one mechanism seen at two resolutions. The overall drift tells you that particle rhythms as a whole have followed the tension of the universe downward. The internal distortions tell you that each kind of particle and each internal structure has its own way of following, and those differences are being written into the fine structure of the light. As our telescopes and spectrographs get more precise, we stopped hearing only "everything is redder" and started hearing "this part of the band is also slightly off the main beat." That is not the universe breaking its own rules. It is matter still singing with the timing it had when the light was born. If we are willing to read redshift and spectral drift as two sides of the same evolving score, the universe stops being a static stage with actors only moving around on top and becomes a slowly changing energy sea in which the instruments themselves are being retuned as they play, writing that changes directly into the light that reaches us. In the next episode we will push this idea into more complex systems and ask why molecules in distant galaxies sometimes look just a bit wrong-sized or oddly shaped compared with their cousins in our labs. Tap follow, share it on New Physics, Clear Universe.